All right. So a couple very important vocabulary words we're going to talk about today. The first one is the midpoint. Okay. A midpoint is going to take a segment and divide that segment into two congruent pieces. Okay. So since we have this segment here, AB, and notice how AM and MB are the same length. M is considered the midpoint. It's in the middle. Okay. If we have a midpoint, then we can say, okay, AM is congruent to MB, and their lengths are equal. So I do have some highlighters in those caddies. If you want to highlight that, you can. It's up to you. But the concept of a midpoint is going to come up a lot. What? Yeah. I then want you to draw segment QS for me. I want you to draw this right here. Okay. Braden, explain to me what those little weird marks mean. Okay, so what's the same length? What's congruent up there? Okay, so QR is congruent to RS is what Braden says. That's what that means. Okay. And since those two congruent segments share R, what does that mean about R? Okay. R is the midpoint. Okay. The next important word we need to talk about is the concept of a bisector. So right now we're going to talk about a segment bisector. Later on this week, we will talk about an angle bisector. But anytime we have the word bisector, we have something that is cutting our geometric figure in half, okay? So if we have a segment bisector, then that means we have something going through the segment at its midpoint, okay? It is bisecting, it is cutting our segment exactly in half. Okay, so you can see in this picture right now, we have segment AB. We know M is the midpoint. So we're going to call line CD the segment bisector, because it's going through the segment, cutting it in half. It's going through the midpoint, but it's cutting it exactly in half. Okay. So I want you to just make a note to yourself over here that just anytime you see the word bisect, it means divide into two equal parts. Now, a segment bisector could be a point, it could be a ray, it could be a line, it could be a segment, it could be a plane. There's so many possibilities, but as long as it's going through the midpoint or it's at the midpoint, then we're talking about a segment bisector. Okay, so draw this picture. We are going to talk about a couple things with this picture. Okay, the first thing I want to know is, do we have a segment bisector in this picture? There is nothing cutting. What is it? Okay, point S is our segment bisector because it is cutting our segment into two equal parts. Okay, now it's just like sitting on the segment. Okay, right, but it's still the bisector. Okay, it is sitting right there, cutting it in half. All right, so I want to know if RS is 24, then what is the length of ST and what is the length of RT? So don't say anything yet, please. I just want you to think about it. Okay, what would be the length of ST? I think Presley. 24. Okay, we know that RS and ST are equal. Okay, so they equal the same thing. So, Sam, what does that make RT? 48. Okay, so let's talk about some patterns. If we have a segment bisector, what is going to be true every time about the whole segment compared to one of its parts? So like one of its parts is RS, the other part is ST. What's going to be true about the whole segment if we have a segment bisector? The length is going to be, okay, twice as long. Okay, which is, yes, always going to be an even number. Okay, so where your head's at. Okay, all right. Now, when I give you numbers, that's not going to be the hard part. Okay, the hard part, and I don't even know if I would consider this hard, but the trickier part is when I give you the lengths in terms of an algebraic expression. So this time I'm going to tell you that NE is 6x minus 7 and EB is 5x plus 1. And I want to know what MB equals. In order to determine what NB equals, what would we first need to determine? What do we have to find first? We gotta know what X is. Okay, now we know that NE is 6x minus 7, and we know that EB is 5x plus 1. Well, what do we know about segment NE compared to segment EB? They're the same. All right. So what we can do is we can say, okay, 6x minus 7 equals 5x plus 1. Subtract over the 5x, add over the 7. What does x equal? Okay, we know that x equals 8. Now, is that what I asked you to find? No, I did not ask you to find 8. I want to know the length of segment NB. So what are we going to have to do with x equals 8? Plug it back in. All right, so we know that NE is 6x minus 7. What does that make NE? 6 times 8 minus 7. 41. Okay. All right, well, if NE is 41, what is that going to tell us about NB? 41. I'll let you think of that. Oh, NB. Okay, so Nora gave me the answer for which segment? EB. So if NE is 41 and EB is 41, then together NB is going to be 82. Okay, so make sure you really think about what piece they're asking you to find, whether it's like your homework assignment or me on a quiz or test or whatever. But just be careful that you're not going so fast that you stop at x equals 8. Oh, you didn't answer the question. Or make sure you really consider which piece you're solving for. Also, if there's not a picture, if they just give you information, you better draw a picture, because it's not every time you're going to set these equal to each other. They might give you NE and NB, let's say, and then you're going to have to set your problem up a little bit different. You wouldn't set the two segments equal to each other. So if there's not a picture, draw one, and based on your picture, create your equation. Okay. All right, let's go to the next page. Okay, the midpoint formula. So we just talked about segments. Okay, we talked about segments and we talked about midpoints of a segment. Well, if we are in the coordinate plane, this is how we find a midpoint. Okay, we are going to take the average of the x's and the average of the y's in order to determine what our midpoint is. Okay. If I start at 2 and I end at 6, I know my middle is going to be 4, because 2 plus 6 divided by 2, that's how we would find the average. Okay, so when you're asking for the midpoint, you're going to take the x's and find the average. You're going to take the y's and find the average. Okay, so let's talk about what that looks like. Let's find the midpoint of -2, 5, and 3, 7. All right, so this is all you're going to do. You are going to take the x's, -2 plus 3, add them together, divide them by 2. You are going to take the y's, 5 plus 7, add them together, divide them by 2. So I put my x's together, I put my y's together. What does that give us for a coordinate? Okay, so whether you write it as 0.5, you can write it as 1/2, and then 6. This is the midpoint of our line segment with endpoints of -2, 5, and 3, 7. All right, you try this one. Okay, I want you This is a 2. 4, -3, 2, 9. Find me the midpoint, please. All right, Benjamin, what'd you get for your coordinate? 3, 3. Do you agree? Okay, awesome. Okay. The next thing and the last thing we're going to talk about is the distance formula. Okay. Now, if I remember right, you have not seen this formula before. Okay. So I want you to do, at least those of you who have been highlighting, go ahead and highlight it. Okay. And then I'm going to have you just drop your pencils and highlighters, and you're not going to write down what I write down right this second. Okay. You're just going to watch me. Okay. So what our goal is to find the length of this segment right here. Okay. So like in the homework over the weekend, you had to find the length of segments that were either horizontal or vertical. This segment is at an angle. Okay. So we can't just like count the tick marks. Okay. But if we draw a right triangle, we can use what's called the Pythagorean theorem. Do you remember the Pythagorean theorem? A squared plus B squared equals C squared. So let's call this side A, this side B, and this side C. So if I wanted to solve for C, I would square root both sides to get the square root of A squared plus B squared. Do you understand how that happens? Okay. If I want to get rid of the square so that C is by itself, I would square root both sides. Okay. This is what you just highlighted. You just don't see A, B, C. Okay. What you see instead of A, okay, they're talking about, okay, well, if I count this distance right here, I'm basically taking this X coordinate minus this X coordinate. So instead of A, you see the X minus the X coordinate. Okay. And instead of B, you're seeing, okay, well, this vertical distance I can count. Boom, 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 boom. Well, to do that, I can just subtract the Y coordinates. Okay. So this is what you see. It's the Pythagorean theorem. It just is in disguise. Okay. So this is how we're going to find the distance in between 2 points. So I want to take our same 2 points from before, -2, 5, and 3, 7. Okay, go ahead and write those down. What I want you to do is I want you to draw x1, y1, and x2, y2 above those coordinates to help you. Okay. So this is what we're gonna do. In order to find our distance, and I'm just gonna write D for distance, I'm gonna make a big, long square root sign. And in our formula, we need to take x2 minus x1 squared, okay? And I'll tell you right now, it does not matter which one you identify as x1 and which one you identify as x2. You're gonna get the same answer no matter what, okay? But in this case, we wrote 3 as x2 minus -2 for x1. Okay. Plus our y's, we're going to take y2 minus y1 squared. So we're going to have 7 minus 5. So then what you're going to do with this formula, we're going to take what's in the parentheses. We're going to figure that out first. So what's 3 minus -2? Okay, so this becomes 5 squared. And then 7 minus 5 gives us 2 squared. So underneath, we have 25 plus 4, which is just the square root of 29. Okay. What took all your calculators off of the table? If you have your calculator, what is the square root of 29? What is it? So 5.4. Do we agree with Braden? Okay. So I would accept either one of those answers, square root of 29 or 5.4. If you're going to put it in as a decimal, then I want to see the square root you put in your calculator, but I'm also fine with you leaving as a square root.
What's the point about the square root of 2?
Oh, you've never seen that before. So this is like, I'm approximating. So the square root of 29 is an irrational number. It's going to have decimals that go on forever. So since I'm cutting it off, since I'm rounding, then I'm approximating. So the squiggly equal sign is an approximate sign. Okay. Now, some of you can look at that formula and you are good to go. Some of you are a little nervous about the formula. So I'm going to give you this. You can use it or you can give it back to me if you don't want to use it. Okay. This is just kind of like a fill in the blank. I wouldn't let you use this like on your quiz on Wednesday, but as you're practicing the formula, if you want to use this to help you keep your ducks all in a row, here this is. Okay. So what I want you to do, whether you use this or not, I want you to find the distance between our 2 points from before. So I want you to find the distance between the coordinate 4, -3 and 2, 9. Don't think you need it. You should be getting the same answer as your elbow partner. I would love for you to check in to see how that's going. Alexa, what'd you say you got?
48.
The square root of 148. Do you agree with Alexa?
I almost got it wrong, but then I realized that minus the negative is, well,
Yep. When we subtract, we add the opposite. Okay. Approximately the square root of 148 is what? 12 point something. Benjamin, 12 point what? Oh, no. Let's see. So we have this button right here. You're just gonna put square root and then type in 148 and hit equals. Oh, why is it giving you that? Mode. Okay, I'm gonna have to play with that in a little bit. Oh, let me see. Oh, you need to do the square root symbol first. So do second and then that and then 148. Yes. So 12.2. Those of you keeping track. All right. So this is what I want